Example 1, for what values of k is the function continuous? So in this example, or these examples, it's similar to the previous section, but see, I'm not trying to determine if these functions are continuous. I'm going to use the rules for continuity to figure out what k is. So basically, it's like they stuck in an extra variable and we're trying to figure out what that variable is, like what k can possibly be to actually make these functions continuous. So hopefully you can recall, functions are continuous. There's three requirements that need to be met. And to start off, you want to know that if you were to plug in your x value into the function, it exists. So here, the numbers we're going to be, our x's that we're going to be using, 3. Okay, well, the part of this piecewise function where 3 should actually go is here. So ideally is I would plug in my 3 and I should get a number. Well, see here, I don't know what k is. So we can kind of skip that part. We could just jump straight to making sure that the left and the right hand limits are the same. So in order to figure out what k is, we need to make sure the left and the right are equal to each other. So that's how you start this off. So let's see. The left, so x is less than 3, or x is less than or equal to 3. So this is the left, and this is the right. So the idea should be that the left should be equal to the right. Now see, our x's, we know what the x equals. It's 3, or rather what we're using in this problem. K is what we're trying to figure out. So what you do is you plug in 3, because that's known to us. So now it's k times 3 instead of x. But of course, we always write the numbers first. So 3k plus 1 equals, and now it's k times x squared, so that's 3 squared, so that's 9. So 9k minus 1. Now the idea is that these should equal each other. So what do we have? We have a simple algebraic equation with a variable that we can ideally solve for. So let's see, I'll subtract the 3k from both sides, right? And that goes bye-bye. So now I have 1 equals 6k minus 1. And then add 1 to both sides. So now that's gone. And I have 6k equals 2. And in the wonderful world of algebra, if I want to get the k by itself, you need to get rid of the 6, which is being multiplied. And the opposite of multiplication is division. So divide by 6, divide by 6. So voila, k is 1/3. Or 2 over 6. You do not have to simplify in this class. But see, now, this function has to be continuous as long as the left and the right hand limits are equal to each other. And the only way to do that is if k equals 1/3. So this is another use for limits in continuity. So b is the same thing. We have a k embedded in this piecewise function, and we need to figure out what k equals. So we're just going to do the left and the hand right limits equal to each other, because remember, if a function is continuous, then the limit exists, and the limit exists if the left and the hand right limit are also equal. Okay, so let's see, red. Let's do red. So 3x cubed, right, that's the left, is going to equal the right, so k times x plus 5. Now, our x value is 2, right? That's the point that's come into question here, because that's where the pieces come together. So we're going to plug in the x equals 2, so 3 times 2 cubed equals k times 2, which is 2k, plus 5. 2 cubed is 8, 3 times 8 is 24. So then this is just a regular old algebra equation. Subtract 5 from both sides, minus 5, minus 5. I get 2k here left, and then 24 minus 5 is 19. And so, like previous, divide by 2, right? To get the k all alone by its lonesome, divide by 2. And then k is equal to 9.5. Now, could I have left it as 19 over 2? Definitely. Would I prefer that you just leave it as a fraction? Yeah, because what if you make a mistake? A boo-boo can cost you a point. Um, so definitely, you can go ahead and start learning from now. You don't have to simplify. You can, fractions are numbers too, okay? So example 2, find the constants a and b such that the function is continuous for all real numbers from negative infinity to infinity. So this is the exact same thing. The only difference is that now instead of just one missing number k, I have two missing numbers a and b. And I want to point out, notice that they are referring to these numbers as constants because they are constants. They're just numbers. They're not actual x's and y's. They're not variables in the sense that, you know, I plug something in and I get something out. These are just the numbers. They're constants. We're just trying to figure out what they are. Now these piecewise functions are a little more intricate because instead of just being two pieces, I've got three pieces. But the same rules apply. So to start off with A, or part A here, I need the left and the right hand limits to be equal, but I also need to know what x's I'm working with. So to start off, if I focus on these two, okay, the left, x is less than or equal to negative 1, so this is my left, and then the other piece, let's see, the x is greater than negative 1, so this is my right. Now what number do they have in common? Well, they have the negative 1 in common, so that's going to be my x. So I have to do two different equations. I'm going to do this twice for the same piecewise function. So the left is going to be 2, and it has to equal the right. And the right is ax plus b. Okay, so I'm going to plug in my x, and the x that I'm going to use is the negative 1, because those two pieces, the only place that they touch is at or near negative 1. That's what they have in common. So my x is negative 1. So that's what I'm plugging in. So 2 equals a times negative 1, which is basically negative a plus b. Okay, so that's it. At this point, in the previous example, we just do some algebra to solve for the variable, right? And remember, I'm using the word variable because these are systems of equations. I don't mean it's an x or y. So in this case, I have two different missing terms here. I have an a and a b. They're not the same. We cannot solve an equation when there's two unknowns. So that's as far as I can go with that part. But now if I move on to the other, the final piece of the piecewise function. So see down here, if I use this one and this piece, see I have to do two at a time because it has to be the left and the right. Now, well, what number do they have in common? Well, they have the 3 in common. Okay, so then for the ax plus b, it says x is less than 3. So then that means that this is the left. And for the last piece, the negative 2, it says x is greater than or equal to 3. So this is the right. So you see, when you have more than two pieces of a piecewise function, the left and the right depends on where you're looking. So now, for these two, I have to make sure that the left and the right are equal. So ax plus b equals negative 2. So once again, I need to plug in x. Okay, what is the x that I'm dealing with here? And it is 3. My x is going to be 3 because that's what they have in common. So plug that in. So a times x, which is a times 3, which means basically 3a, plus b equals negative 2. Okay, so now, oh boy, back to Algebra 1. I need to solve for a and b. I need to figure out what a and b are. Well, I have two equations. I have this one, and I have this one. And I can solve for these variables if I use both equations. And there's several ways you can do substitution. You can do elimination. And then there's the way that we're not going to do, which is a graph and then see where they intersect. That doesn't make sense. But substitution and elimination are totally up for grabs. And I'm just going to do substitution. So what I'm going to do is I'm going to take the blue equation and I'm going to solve that for b. Okay, I'm going to isolate the b. So to isolate the b, I have to get rid of the negative a. And the way to do that is to add a. So now I have 2 plus a, or a plus 2, equals b. So see now that I have that, I know that b, wherever I have a b, I can replace that b with 2 plus a, right? That's the whole point of substitution. So if I look at my green equation, I do have a b. It's right there. Well, see now, instead of that b, I'm going to replace it with 2 plus a. And in essence, what have I done? I have an equation now where there's only one thing I don't know what it is, the a's. The a's are just one unknown rather than two unknowns. So algebra. 3a plus 2 plus a equals negative 2. I've got a total of 4a's plus 2 equals negative 2. Let's see, subtract the 2 from the left over to the right. So now I have 4a equals negative 4. Isolate the a by getting rid of the 4 by dividing, because currently they're being multiplied. So then now a equals negative 4 divided by 4, which is negative 1. So now that I know a is equal to negative 1, my job is to figure out b. And the easiest way to do that is to come back over here and be like, OMG. B is equal to 2 plus a. See, a I already figured out is negative 1. So b is equal to 1. And there you go. These are the values of these constants that will make this piecewise function continuous. And so for part B, you're doing the same exact thing. You're just repeating. I'm just going to move this stuff out of the way. So for part B, we're going to do the same thing. This is the left and this is the right. When I'm looking at these two pieces, right, x is less than negative 1, and then for this part, x is greater than negative 1. So my x for this part is going to be negative 1. So a times negative 1, I'm going to go ahead and start plugging in the x's. Minus b. Okay, that negative 1 is because this is supposed to be x, and I went ahead and just plugged it in. Equals 2 times negative 1 squared plus 3 times a times negative 1 plus b. Okay, so those are the first two pieces. Trying to determine what that equation is going to be. So let's see, let's simplify this. I have negative a minus b equals negative 1 squared is just 1, so this is 2. And then 3 times a times negative 1 is negative 3a plus b. So there's my first equation. I cannot solve this for one variable. I can't solve this because I have two variables or two missing terms, two unknowns. I can solve it for a variable if I want to use substitution. But I'll do that later. Okay, the next two pieces, I'll do those in red. These two pieces right here now. Now this is the left and this is the right, and the number they have in common is the 1. So I'm going to do the same thing. I'm going to set them equal to each other. So 2 times 1 squared plus 3 times a times 1 plus b, and that should equal 4. Okay, so simplify this and I have 2 plus 3a plus b equals 4. Now looking at both of these equations, which one looks friendlier to use if I wanted to do substitution? And hopefully you're saying the one at the bottom. And yes, I would agree. It does look a lot friendlier. So what I'm going to do for the red here, I'm going to isolate the b because it has no coefficient, no number in front. See, that's a good thing, because then if there were a number there, I'd have to divide by it, and then that just brings in fractions and complicates my life. So I'm going to solve for b. And that means I'm going to have to subtract 2 and subtract 3a, right? I'm moving them over to the other side. So subtract 2 and subtract 3a. So I get b equals, let's see, 4 minus 2 is 2, and then minus 3a. Okay, so that's what b is. So now that I know what b is, I can go ahead and substitute in that purple equation on top there. Anywhere there's a b, I can just plug in 2 minus 3a. But, of course, I could take that purple equation up top there. I could simplify it a little. I mean, that wouldn't hurt. So I'm just going to go ahead and move this stuff a little bit out of my way. Okay, so the purple stuff. The purple equation here. Well, let's see. Let's go ahead and add... Oops. Where did I get 4 from? I do not know. Let's go ahead and add 3a to both sides. Add 3a. So let's see, negative a plus 3a. That's, positive 2a. And then, let's go ahead and subtract b from that side also. Subtract the b here. So now I have negative 2b's. I have 2 b's that are negative. And that equals 2. Okay, made my life a little easier. So then, now I know b is equal to all of this here. So wherever there's a b, I can just replace it with 2 minus 3a. And that's ideally what I'm going to do. So 2 times a minus 2 times 2 minus 3a equals 2. So now there's just one unknown. That's the a's. So 2a minus, let's see, 2 times 2 is 4. See, it's technically negative 2, so it should stay negative. So minus 4. And then negative 2 times negative 3a, so it's positive 6a equals 2. So 2a's plus 6a's, that's 8a's minus 4 equals 2. Add 4's to both sides. I'm running out of room, so this is an arrow here, people. Add 4 to both sides. I get 8a equals 6. Divide both sides by 8. A equals 6 over 8 is perfectly fine, or 3/4. So now that I know that A is 3/4, I would just take that and plug it in here to figure out what B is. Okay, so B is equal to 2 times 3 times 3/4. So B equals 2 minus, so 3 times 3 is 9/4. And yay for fractions, right? In order for me to actually subtract, I need common denominators. So 2 is actually 8 over 4, right? Because 8 divided by 4 is 2. Minus 9 over 4. And so then I get 8 minus 9 is negative 1/4.